Hey math fans, welcome to Chapter 10, Section 4, Inscribed Angles. At the top of the notes here, I have some definitions to go over with you. It says, an inscribed angle has a vertex on a circle and sides that contain chords of the circle. So in circle C over here, angle QRS is an inscribed angle. So if I zoom in real quick, you'll see that this is circle C, and then QR is a chord, RS is a chord, and together they form an angle. This is an inscribed angle. An intercepted arc has endpoints on the sides of an inscribed angle and lies on the interior of the inscribed angle. In circle C, minor arc QS is intercepted by angle QRS. So I just think of intercepted arcs as the arc that the angle is eating. That's what's helpful for me. Next, it says there are three ways that an angle can be inscribed in a circle. Case 1, it says center P is on a side of the inscribed angle. So that means this line that goes through center point P is a diameter. In case 2, it says center point P is on the inside of the inscribed angle. And in case 3, it says the center point P is in the exterior of the inscribed angle. And then we have this theorem 10.6 called the inscribed angle theorem. And it says if an angle is inscribed in a circle, then the measure of the angle equals 1/2 of the measure of its intercepted arc. So measure of angle 1 back here is an inscribed angle. The intercepted arc AB is going to be twice that of angle 1. So this value will be half of this, or this value will be double that of this, however you want to think about it. So in my first example here, I'm looking for measure of angle P, and so you see the intercepted arc of 70. That means angle P will be half of that, so angle P will be 35 degrees. And then I'm looking for arc PO. Well, 56 is the inscribed angle, and it is eating arc PO, so that means you're going to double it, and it's going to be 112 degrees. In this one here, it's looking for measure of arc WX, which is this little arc right there. So first thing we need to do is find the arc WY, and that's just going to be double the inscribed angle of 57. So 57 times 2 is going to be 114 degrees. And then if we look at arc XY, that is a semicircle. From X to Y, it goes through the center point, making that a diameter. So therefore, this is half of a circle. And so we know that the sum of the degrees of a circle is 360 degrees. So this is going to be 180 degrees. And so we just need to do 360 minus 114 and minus 180 to figure out what measure of arc WX is. And with that, I get 66 degrees for measure of arc WX. This next property states that two inscribed angles that intercept the same arc of a circle are related. How are they related? Well, if two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So if you look at this picture, angle B, if I were to trace the red line of angle B, is intercepting the arc AD. And angle C, if I were to trace the blue line, it is also intersecting arc AD. So therefore, you can say that angles C and B are congruent because they are intercepting the same arc AD. So in example 2 here, I have angle T and angle U intercepting the same arc of SV. So therefore, I know that these two angles are going to be congruent to each other. So I'm just going to set these equal to each other and solve for x, and then I can plug it back in to figure out the measure of angle T. And then since I figured out the measure of angle T, I'll also be figuring out the measure of angle U, since they're congruent. So if I'm going to set them equal to each other, I'm going to have 3x minus 5 equals 2x plus 15. And so I just need to get my x's on one side. So here I can minus 2x under the 3x, and 3x minus 2x is just going to give me 1x, or x. And so then I can add 5 to the right-hand side, and 15 plus 5 is going to give me 20. So I just get 1x equals 20. So therefore, we're going to plug it back in, and angle T was the 3x minus 5, although it's really not that important which one you plug it into since you set them equal to each other. But measure of angle T will be 3 times 20, so I know that's 60, 3 times 20, minus 5 is 55 degrees. If you want to plug it in the other one just to make sure you did it right, because they should equal the same thing, measure of angle U is going to be 2x plus 15, so 2 times 20 is 40. 40 plus 15 is 55 degrees. So we know we did it right because both of these equal 55 degrees. Next I wrote triangles and quadrilaterals that are inscribed in circles have special properties. An inscribed angle of a triangle intercepts a diameter or a semicircle if and only if the angle is a right angle. So if arc FJH is a semicircle, FJH, then measure of angle G, the angle that is opposite of it, is going to be 90. And if measure of angle G is 90, then arc FJH is a semicircle and FH is a diameter. So pretty much if you got an inscribed triangle and one of the sides are a diameter, then you have a semicircle on one side, and on the other side you have a right triangle. So the side that's opposite of the diameter will be the right angle, and the diameter side, FH, that'll be your hypotenuse. So here I'm going to find measure of angle F, and so I have FH as my diameter. That's going to be the hypotenuse of my triangle, making angle G is just coincidentally that this angle G is also a right angle, as the example picture was. But basically, we know that the sum of all the angles in a triangle are 180 degrees, right? And so we start with 180 degrees, and then we know angle G is a 90-degree angle. It's a right angle based off of that property. So that means the sum of my two angles is going to have to equal 90 degrees. So I'm just going to add together angle F and angle H. In other words, I'm going to say 4x plus 2 plus 9x minus 3, and I'm going to set that equal to 90. So 4x plus 9x is 13x, 2 minus 3 is negative 1, and then I'm going to set that equal to 90 degrees. And so I can just add 1 to the other side, and 90 plus 1 is, of course, 91. And so I can divide both sides by 13, and 91 divided by 13 is 7. So if I were to go back and figure out measure of angle F, I just say measure of angle F equals 4 times 7, that's 28, plus 2 is 30 degrees. And just for the heck of it, I'm going to figure out measure of angle H too. Now granted, you could just do 180 minus 30 minus the 90 that was given to you, and you get 60 degrees. But also you should get 60 just plugging in 7 to the measure of angle H expression. So 9 times x turns into 9 times 7, which is 63, minus 3 degrees, which is 60. So yeah, 30 plus 60 plus 90 equals 180. So that's how you know you did it right, because all three of your angles add up to 180 degrees. This last property says, while many different types of triangles, including right triangles, can be inscribed in a circle, only certain quadrilaterals can be inscribed in a circle. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So, if quadrilateral KLMN is inscribed in circle A, then angle L and angle N are supplementary. What does supplementary mean to you? Remember, supplementary means they're going to add up to 180 degrees. So if I add up L plus N, it'll equal 180. We're used to parallelograms where the consecutive angles are going to be supplementary, but here it says the opposite angles are supplementary. So it also says that angles K and M are supplementary, so that means angle K plus angle M equals 180 degrees. And since it's a quadrilateral, the sum of all the angles need to equal 360, so yeah, 180 plus 180 is 360. Example 4 says, the insignia shown is a quadrilateral inscribed in a circle Find the measures of the missing angles. So looking at this picture, the one thing I'm given is that angle V is 90 degrees. And since opposite angles are supplementary, meaning they add up to 180, and we know that 180 minus 90 is 90, that tells me that the angle across from it, angle S, is also a right angle. So I'm just going to put a little right angle symbol right there. And just to show my work, I made note of it down below right here. And we also know that these two are opposite of each other, so therefore they're going to add up and equal 180 degrees. So I'm just going to write 8x plus 4 plus 14x equals 180. Do not equal these to each other. You're going to add them up and equal them to 180 because they are supplementary angles. So let's combine our like terms. What's 8x plus 14x? That's going to be 22x. And then we have plus 4 equals 180. So let's minus that 4 over to the other side. 180 minus 4 is going to be 176, and that's going to equal 22x. So 176 divided by 22 is going to give me 8. So if x equals 8, then I can figure out my missing angles of t and u. So measure of angle u is just going to be 14x, so that's 14 times 8. And 14 times 8 is 112 degrees. Measure of angle t, 8x plus 4, is going to be 8 times 8 plus 4. And 8 times 8 is 64. 64 plus 4 is 68 degrees. And you can just do a quick little mental check. What's 112 plus 68? That's 180 degrees, which is what they should add up to. So that means you did it correctly. And so that's going to wrap up my notes. Thank you for watching. I hope you learned something, and goodbye.